Hello and welcome back. It is me again, and today we're going over the basics of modern CPU architecture. And not just CPU, but I guess modern computer architecture. Desktop computer architecture. So if you know nothing about desktop computers, then this should serve as a decent intro to what things do, basically. And yeah, we'll just get going. We're going for Mothair today as Samsung. Okay. Fun start. Ow, that hurts so bad. Because you're a champion, I know it, off the top of my head. I will now go in here and take damage twice and then use the pill. That way it can't be a bad trip. And I am a genius. Oh. The world, the Empress, huh? I'm fine. This is fine. I'm definitely... There we go. Give it to me. Go, 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 go. Nice. Glad I can pick that through the thing. Oh, that was so close. That was so close. It could have been really bad. Oh boy. I'm not making this explicit, so let me do it and make it explicit. I should be at 1/2 heart right now. So, oh, in fact, you can see it because I'm leaving little pee stains. Yay. There you are. Anyway, yes, we are talking about CPU architecture because why not? It's something I wanted to talk about at some point. Even though I built my own computer, I don't actually know very much at all about hardware. More of a software guy, Not interested in you. Although you would be very beneficial for the next floor, Or the next two, possibly, but that's okay. I want something even better. And yes, I could bomb it, but I would prefer not to. So I will be learning some today as well. That's my point. Please give me a penny. Please? Pretty please? I want a penny. I want it. From somewhere. No? Bomb. Okay, well... yeah, I guess it's bombing time then. At least I have a key. Hopefully I don't die, though. That's my bigger concern at the moment. Now, I can only do that once, and this was a terrible reroll. Alright, I would have preferred the other. Oh well. This could help in a... in a very limited way, sometime. Not here, that's for sure. Okay, whoa, and I have killed him, and I have health, which means I shouldn't die. I mean, I believe, if I recall correctly, I should have gotten health back anyway. Curse of the Blind! Thank you so much, really needed that. But, hey, maybe I didn't. I only have 2 hearts right now. Hey! First time seeing you. No. I'm gonna do it. Did I need to? No, not at all. Did I want to? Yes. Yes at all. Now, can I find a petrified poop quickly? I mean, this is great. I'll gladly take that. Anyway, let's get started on... Oh! Right. How to jump? Sure. Yeah, that's fine. Let's get started on modern computer architecture. We're starting off by describing the functions of CPUs. The many functions of CPUs, in fact. I'll keep that in mind, and I will forgo it. But rather than forego, I will just go, you know? Go, 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 go! Ow! And we got that, and we got... I'm not gonna make it to the boss. That's fine. Okay. So... CPUs. Petrified poop, petrified... No, okay. Worth a shot. The first operation to talk about when it comes to CPUs is that they fetch, decode, execute, and then write back data. This is the instruction flow of a CPU. So this is a cyclical process where the CPU, or central processing unit, to be exact here, first fetches instructions from memory, decodes what to do, executes the operation, and then writes the result back before fetching something else. That is... Ow... That's okay, I hate Samson. That is the most abstract way of describing how a CPU works, but there are more operations to a CPU than just that. And, okay, that's... Oh, okay, that's cool. That's cool, too. What am I saving the Empress for? I don't know. A floor where I get a different card. Or maybe Mother. Yeah, I hate playing Painted Samson. Sorry. Sorry, not sorry. But that's really good. Okay, nice. It's not worth it going back for that health, so we march onwards. Next, let's talk about parallel abstraction, that is concurrency and pipelining. So as you may be aware, CPUs can actually do multiple things at once, sort of. Uh-oh. Yeah, that's... Oh, I did reach him. I wasn't sure if I'd be able to. Huh. I know it's typically the GPU's wheelhouse to do multiple things at once, but the CPU does as well. So multiple instructions can move through the CPU at overlapping stages, and this is called pipelining. And then multiple instruction streams or data sets can also be processed simultaneously. This is multi-threading, SIMD, or multi-core processing. SIMD, single instruction, multiple data, I think, off the top of my head. I'm pretty sure that's what it meant. Means? Meant? My brain is a work of art. Infamy! Yay! Wish I could enter the boss challenge room, but oh well. On the bright side, I get to do that, and then bombs are key. Neat, it's one either way. Ooh, not you. I hate you. At least you're an interesting boss, you know? You got that going for you. Yes, so ever since basically the year 2000, CPUs have had multiple cores. Ever since discovering that if you know, the technology is there to actually just have one core and then like hyper optimize it, but the problem around the year 2000 was that if you made a single core work any faster than it was at the time, then the surface of the CPU would actually be hotter than the surface of the sun. You gotta be kidding me. I wanted money. I mean, I'll take the speed. Thanks. Ugh. Whatever. Also, I really hope I get 2 bombs here. That'd be nice, you know? I'm not gonna fall for this trick. I've fallen for it before. Don't make me go melee mode. Do not... No melee... Okay, good. Good. Phew. Remember the guys at the top and the bottom. There. Key? No, not good, not good. Bombs, please, bombs. Come on, game. Bomb it up now. Oh. I didn't realize you were listening, game. Thank you. That's, yeah, thanks. Also, if you can't tell what's going on there... Uh-oh. I'm jumping. That's what that was. Ooh, and now I can hit him. Go, 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 go. Ha 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 ha! That was awfully good. Mighty good, even. Now I need another melee mode, because I don't like this guy. Oh, well. Excellent. Excellent. Give me 2. Oh. Anyway. So the solution around, again, the year 2000 was, rather than continuing to hyper-optimize a single core, you would instead transition to multi-core processing, where the CPU is able to do, or to split up some operations. That's the first time I've ever done that, isn't it? In this save file. I thought for sure. Wait a minute. What? Are you sure? I guess it's up here. Weirdo. I have money now, though. That's good. Was there anything at all? No, it's just a pill. And, yeah. I'm just a pill. Sitting on Capitol Hill. Oh, it was! First guess. Wow. Oh. Okay. That's fine. Next, CPU operation type. Function. Basic function. Rather, I shouldn't say operation type. That might suggest other things. Whoa. Whoa, okay. I can jump into the cursed room, right? I think. No? Huh. That's a shame. I feel like I should be able to. I can understand not being able to jump out, but oh well. Oh, I should have had him blow up that rock. Uh-oh. Uh-oh. And it's a dead-end room, too? Oh, hello. There's a third? Oh. Go, over there. Yes. Give me the card. 10 parents? Absolutely. Nice. This is a lot of money now. No, wait, I can't reach that pill. Oh, phooey. Anyway, next purpose of the CPU, if you will, because lack of a better term here, is resource coordination, that is scheduling and allocation. So the CPU acts as a resource manager, scheduling the use of execution units, this is ALUs or FPUs, memory access, uh-oh, hold on, whoa, oh, nice, that was it, cool, memory access, that is caches and buses, and registers and temporary storage. So it manages resources. At least computation-based resources. Not overall operating system resources. That is later, with the motherboard. Sort of. I'm just not sure how to handle this room. I don't feel like putting in too much mental effort here. Yeah, there we go. Let's do... Oh, okay. Oh, I was oh, nice. I was expecting more time to smack these guys if I rushed in here in melee mode. Oh well. Whoa! I am rich. Richity rich. I am actually moderately wealthy. I'm like upper middle class for Isaac right now, aren't I? Ow. Okay, time to get the soul heart. Melee mode. Melee mode. Go, go, go. Nice. Go, go, go. I don't know where I'm going. Oh, but I didn't get there in time. Wait a minute. Don't break the barrel. I need it, maybe. Whoa, okay. I'm gonna hope the secret room isn't there. Actually, I know it's not. Never mind. That's anticlimactic. Where are you? Ah, ooh, he didn't touch me. I thought he did. I thought he would've. Next up, Memory Hierarchy Awareness. I wonder what calendar day that falls on. The CPU interacts with a tiered memory system, if you didn't know, which aims to keep frequently used... hold on, I'm not going to be able to read this. There. Which aims to keep frequently used data nearby in registers and L1 caches. I thought those were the same thing. Am I wrong? Maybe. Maybe. But also balance speed versus capacity in the other various memory caches, such as L2 cache, L3 cache, RAM, and storage. Long-term storage. You know, I have not benefited at all from being able to jump. So Alabaster Box it is. I have plenty of health. Although, you know, looking at some of my previous Samson runs here, I do drain health very quickly as Samson. Because of some reckless gameplay. Like that. I mean, that wasn't reckless, just bad. Like that. It's quite simple, really. Huh. On the bright side, we have you. I don't know what I'm going for here, I want more. Okay, I should actually stop, though. You know, I never hit the slots, I always go for the shell game. But I may as well go for both. Because I do genuinely need health back, that way I won't lose my bone heart, you know? I mean, that works. Regen? Yeah. Anyway, just basic concept here. L1, L2, and L3 caches are onboard memory caches on the CPU itself, where L1 is the smallest and L3 is the largest cache of memory. Again, that is on the CPU so that it's able to immediately access the data stored on there and shuffle it around if needed. L1 is what it is basically currently operating on. I wouldn't mind. Yay! I still need more health, which means bye-bye. You did not provide me with health. Let me take regen and come back for the counterfeit penny in a minute here. Oh, not what I expected. I don't like this. Oh, okay. Can you regen already? I'm growing impatient here. Boop. No? Oh. Well, one soul heart. Still no pill. Where? Oh. It's up here. Yeah. I'm gonna be all out of bombs at this rate, but oh well. Yay! I do need more luck. I always need more luck. Is this only a single heart? Yeah, it was. Okay, I just need any amount of health at this point. Is that Linger Bean or Mega Bean? Oh, no. It would have been better. I just really need to hope that regen kicks in soon. That way I don't lose my Bone Heart. Oh, great. You know, I'm gonna use it. I need the extra damage and speed for this guy if I really want to save my Bone Heart, because I really do. I really do not want to lose my Bone Heart here. Please regen. Please regen. Please regen. Please regen. I'm dying out here. Don't do that. Don't do that, bud. Oh. That works. Begrudgingly, but it does work. Okay, back for the counterfeit penny. One final... Not here. One final say on the L1 through 3 caches here is that they are pretty small. They are in terms of, like, kilobytes. I want to say L3 is... No, not... What am I... Where are you? Up there. I want to say... and this could be dated information too, because this is from several years ago, and we're probably already on the next gen CPUs, even though it's only been a few years, but, you know, the rate of progress keeps going up and up. It's accelerating, in other words. I want to say L3 is, like, close to 1 megabyte in size, and L1 is only several kilobytes in size, and L2 is obviously in between. It's something like that. I could fish for soul hearts in the sacrifice room if I find more health. Do it. Do it. Do it. Do it. Do it. Yes! Oh, interesting. One more, please. One more, please. And again, these are distinct from RAM and long-term storage as well, but we'll get into what those are in just a second. Oh, great. More keys, huh? Yay, extra penny. I always forget that this room doesn't actually clear. Next function of the CPU is control logic. This is the CPU as a decision-making engine. I am scared of this room. Go melee mode. Go bananas. Go bananas. Go bazanas. Nice. Oh. Ooh. Go bonanzas. Huh. I thought the same guy wouldn't shoot twice like that, but oh well. I suppose he did. So the CPU contains logic mechanisms that decide what instructions to run next, and handles dependencies, exceptions, and speculative executions. Ain't that neat? Oh. Go. Go bananas. I guess that's what I'm calling it from now on, until, you know, next episode. Because I should be done with Samson by then. Next episode should be the final Samson episode, and I will be glad to be rid of him. Sorry, Samsung. I like your phones, though. Now, I am likely to get an angel room here, so I guess I saved Soul of Isaac for that. You know? That was the worst attempt at hitting that guy. No, 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 no. Get the... There we go. So yes, the CPU has components that help it decide which operations to run next. Sort of meta computations. Very, very fascinating. Next, state machine abstraction. Oh, and let's go in here. Angry fly. Hello, that's a second fly item. I do like fly items. At its core, the CPU is a state machine. That is, it transitions between states based on inputs, such as instructions and data, and it produces both outputs and can change internal states. Now, I had never heard of a state machine before. I first asked a friend who is an actual video game developer about developing video games, and they were like, "Do you know what a state machine is?" And I said, "No." And although I do respect and appreciate this friend, they were like, "Ooh, yeah, you might want to start with that." And it's like, I looked it up. Takes about 2 seconds to understand. I don't see what the big deal is. I don't see why my friend was slightly condescending with it. I don't know. I'm venting at this point. I'm sorry, but it really isn't anything. It just means it has like an enum for different states where it processes things in terms of the CPU anyway. It has an enum for states where it processes things differently depending on the state, and it can just swap between them. And as far as video game development goes, it would be like a state machine would be like logic for whether the character is on the ground or in the air. That's a state machine. That's it. That's everything. That's all you need to know. That's it. It's that simple. I mean, yeah, it's not maybe that simple, kind of. It has its complexities, I'm sure, but like in an abstract sense, it really is that easy. Oh, I know. Oh, I don't have any other hearts. That's a shame. I'll save my Soul of Isaac for when I fill the alabaster box. That's a genius idea. When am I gonna do that, though? It's not happening as quickly as I would like. Oh. Okay. Focus. Focus. Focus, pocus. Do not shoot bone at me. Very rude. Very rude. Very rude, very rude. Uh-huh. Oh. Oh, no, 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 no. Not my bone heart. No, not my bone heart. Not my bone heart. No! I didn't even get an angel room. Let's see, the final function of the CPU is as an energy performance trade-off engine. You know, very simple concept, I'm sure you can understand. Modern CPUs are governed by dynamic trade-offs. They balance performance versus power consumption and speed versus thermal constraints, again because they would get as hot as the surface of the sun if they work too hard or too much, which, fun fact, isn't as hot as the corona of the sun, which, you know, is above the surface. It's weird, it's counterintuitive, but that's physics, baby. Mainly that's electromagnetism, baby. The more you know. At least I think it's electromagnetism that results in that effect. I'm a well-adjusted individual to society, I will have you know. Whoa. No, 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 no. Oh. Get him. Get him. Get him. So that is it for the CPU. Now let's move on to clearly what is the second most important aspect of modern computer architecture, the GPU. Classic. Classic. No. I heard Mom. Nice. Ooh, extra nice. Wow. Not too shabby. I don't like this. Can I please get some soul hearts? I really want them. So, GPUs. Function number one of the GPU is, most important here, massive parallelism. That is what they are designed for, after all. GPUs are designed to perform the same operation on many data points simultaneously. This is SIMD, SIMD, or SIMT. I actually don't remember what the T stands for. You gotta be kidding me. What am I gonna do with that? What am I gonna do with that? I needed a normal shop. It's like every single Samson run, this series anyway, has just been awful. Which is the most mediocre luck possible, which is the worst kind, really. At least in this game. And not a single soul heart in sight. And other S alliterations. So SIMD is single instruction multi-data, and I don't remember what the T stands for in SIMT, but single instruction multiple times? Maybe? Big floor. Oh, neat. Oh, neat. What? Huh? Huh? Yeah, okay. That was frustrating. Maybe I'm just not that good. I mean, I know I am, but maybe I'm not. Maybe I'm dumb. Maybe Samson just makes me upset. I want it. Oh, I want it. I want it so bad. There are several good places here where the secret room might be. Oh, there are significantly fewer places where the secret room might be. I'm gonna say here. Sorry, I meant, over here. What? Okay, hold on. I clearly, obviously, meant up here. I knew I'd be right. I hate half soul hearts, but I'll take it. And let's bomb you for the insurance. Because I'm gonna need it. Anyway, GPUs operate using wide vector-style execution, often organized into warps or wave fronts. I'm actually not familiar with those terminologies, so that's neat. Very neat. I'm gonna lose my black heart right there. As long as I win now, there shouldn't be an issue. I did not win now, so there is an issue. I hate this game. I hate this game. I don't know why Edmund Macmillan tortures me like this. He personally remotes into my computer to torture me when playing Samson. There's a button over here and I need to press it. What is all the way to the... Oh, just more rocks. Cool. Okay. Well, I have money to waste. Next function of GPUs is throughput optimized pipelines. This is what a GPU is, functionally. Rather than minimizing latency for a single task, a GPU aims to maximize aggregate instruction throughput across thousands of concurrent threads. And it may accept high latency as long as many operations complete per unit time. In other words, it's... Oh, cool, yeah. Neat. It's kind of like when I talked about traffic a bit ago. Oh. Yay! Maybe I should have found a way to duplicate that burst or something. I don't know. Get rid of you, please. Oh, I almost got trapped in that corner, and it would have been bad. Die already. Ah. This was a reasonable way to go. Except I need the shop first. So, yeah, it's kind of like when I talked about traffic and how with traffic, there's this sort of... Oh. This idea that you can optimize the total throughput without... Ooh. I can make use of that. You can optimize for total traffic throughput. Total throughput, even though you aren't actually maximizing individual throughput. An individual might not be faster if the entirety of the traffic system is optimized. But... Oh, cool. Okay, let's go farm some soul hearts now. The sum total of traffic may still be optimized. Paradoxically enough, everyone collectively might get there faster, even though on an individual level you might get there a little slower. Kind of, sort of, abstractly. And this is why I bought Restock. On the bright side, this was really close by, you know? That's one. I just need one more. And this is the final shop, right? Yeah, it is. These are so expensive, but I don't even care. This game. Yep. I don't care about Angel Room anything, sorry, Mega Satan anything. My milk! No! Paradoxically, that's what my milk is there for. Crying over. We do this. And that is the final sacrifice. I am 1/2 soul heart short. That is so tragic. I should have bought Restock first. I'm an idiot. I'm a dumb. I am so dumb. Ugh. Oh well. I could use Soul of Isaac in this room, I guess. I don't know. Oh, the Hermit. Oh, the Emperor. Hold on. Give me the Hierophant. Oh, now it's too expensive. Do I potato peel? I don't think I do. I think I keep my health. Yeah. Yeah, I'll go with this. I don't think this is the boss, but it might be. Oh. Color me incorrect. I will explore the rest of the floor for that sweet, sweet, soul heart that's lying around here somewhere. I know it is. It's waiting for me. That would have been nice earlier. Ow. Well, I have nothing to lose at this point. Except my dignity. And my life. I'm not falling for that. Nice. Oh, that's so good. Hey, that's my move. Next function of the GPU is as a task decomposition engine. The GPU expects, oh neat, problems to be split into many small identical subproblems with minimal dependencies, and computations are scheduled across a grid of lightweight execution units. Ah, scary. There was a kill switch back there. Oh man. Oh man, come on, can't you? No, that doesn't count. Wait, huh? I thought it didn't. Did they change it back? Hold on. This is big. Okay. Now I just need more health. More normal health. Go, go, go. Oh. That man just killed himself. What an idiot. What a fool. I hope he's doing okay. Yay! Red health. I would not mind an extra soul heart. Please. Aww. Over here. Ooh. Oh, normally this is the blue heart room. Not red heart and yellow heart. No, fire. Fire, not hearts. I don't know what I'm saying. Oh well. Let's see, I have one shot at the secret room here, huh? Probably there, right? I suppose it could be here. But, you know, I won't. I'll go to the item room. And if you're wondering, I'm saving the alabaster box for the angel room that I'm definitely getting. Gemini is not bad, considering my frequent melee excursions. And nothing else, I don't suppose, so we shove off, as it were. This is Mom. I'm gonna be impressed with myself if I do this without getting hit, you know? I'm sorry to all of my fans. No, 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 no. Ooh. Okay. Don't do that. Huh. Come on. Come on. Did you see that? At the last second. Okay. You know, I'm gonna save my alabaster box another floor, I guess. I may as well. I want to maximize the Soul of Isaac use here. That's my goal. So if I could get 3 or even 4 Angel Room items to reroll, you know, if I kill the Angel statue. Ah, great. Yeah, okay. Ow! I am not in a good position, am I? Let's see, next. Function of the GPU. Hierarchical Memory Awareness. GPUs handle memory within a layered model, which emphasizes locality, that is, shared memory per core group or registers. Okay. Bandwidth over latency, that is, global memory or L2 caches on the GPU. And manual control over memory access patterns by the programmer. The devil. I'll come back for the devil. Next function of the GPU is latency hiding via context overlap. Yay! Wait a minute. Please? No, not this room. Next room? Next room, perhaps? I mean, this wouldn't have been a terrible room to do it. Yes, please. Sure. Not bad, not bad. Could have been better. Was functionally equivalent to the previous room, now that I think about it. And it didn't affect the bosses at all. Oh well. I made my decision. It was thus. Next function of the GPU. Oh, yeah. I mentioned it already. Latency hiding via context overlap. So instead of minimizing latency directly... I don't know how I survived that, but okay. GPUs... Ooh, thank you. Switch between active threads while waiting on memory and rely on fine-grained concurrency to hide delays rather than prevent them. Fascinating. Then we have how GPUs how GPUs function as a minimal control flow complexity, or how they achieve minimal control flow complexity. So GPUs favor straight-line code with uniform control flow and penalize branch divergence where different threads take different execution paths. So minimize your if statements then. Don't forget Soul of Isaac. I need it. I really, really do. I'm finally about to get an Angel Room here. And I could get 4 Angel Room items out of it. The wait will finally have been worth it. Ew! Hey! Ah! That guy never does that move. I hate that move. Yep. I'm focusing. I'm focusing. I'm gonna focus. I'm about to focus. Woo! Sure. Okay, that's really good. But it's not amazing either. I don't really need it, you know? Not at this point. Oh, cool. And observe. And now. Ho, 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 ho. We take Revelation, naturally. We take Trinity Shield, naturally. Active Contrition for that increased fire rate. And I think I'll take Sworn Protector, please. I think it finally paid off. I'm so glad I'm gonna win. Fingers crossed, things could still go terribly, I suppose. Oh. Next, energy and area efficiency for parallel workloads. GPUs prioritize simple cores that are area and power efficient, and high compute density rather than high single-thread performance. And lastly, for GPUs, we have programmable data flow graphs. So conceptually, a GPU operates like a data flow graph. Curse of the Blind. Oh man, that really sucks. Too bad I can't see what items I'm definitely getting from this floor. Oh, Revelation. Right. Hey, bud, don't do that. Hands off your filthy mitts. Hands, take your mitts off, you filthy animal. Aha. Oh. Well, okay. Guess we're going. So, operations flow through a series of stages with many instances active in parallel. This structure is determined largely by the shape of the input data and kernel logic. I have one more list to go through, and that's other hardware that can be found on a CPU or a desktop computer typically. And I will do it after the fact. But for the duration of this fight, allow me to give you the analogy that one of my professors in college once gave on the differences between CPUs and GPUs. Because it's fun and funny. So whereas a CPU represents the height of capitalism, the GPU represents the ideal of communism. What did he mean by that? Simple. In CPU architecture, what you effectively have is one or several extremely optimized employees with their various specific tasks, and quite a few managers that oversee just these few little employees. Many managers for just a few employees, but they are hyper-optimized. They are absolute machines. Their efficiency is to be marveled at. Compare this to GPUs, in which there is a notable lack of efficiency, if anything, but instead what you have is equality. All workers, hundreds, thousands of cores, all working in harmony, doing the exact same steps at the exact same time. And together, it is the totality of their effort that produces the fruits of their computation. And with that, one episode remains of Samson. Of Tainted Samson. Final list here. Other parts of modern desktop computers and basic overview of what they do. So, you have the operating system kernel. You may see, or you may know of, like, kernel errors, or maybe kernel level software or programming or whatever. So a kernel is your software orchestrated control center. It acts as a conductor for all of your hardware. It manages all of your computer's resources, processes, memory, input, output, and hardware abstraction. And it converts user programs into controlled hardware interactions. So it's the mediator between your computations and the rest of your computer hardware. It's what allows your programs to access your sound system or your displays or your mouse and keyboard and everything else. So when they talk about kernel level hardware, they're talking deep into your computer, basically. Next, you have your motherboard chipset. This is your platform management layer. So hardware if you don't want to know what a motherboard even is, then it's the largest chip in your desktop computer, assuming you have one. It's what everything else sits in. It effectively acts as just the main bus for everything. It's what everything else goes through to connect to each other. That's all. But it does have some software components of its own. So, the motherboard chipset. These are hardware circuits with firmware level software, often in the form of microcode, and this motherboard chipset coordinates data flow between CPU, RAM, GPU, storage, and peripherals, and manages low-level system features like PCIe lanes, USB ports, and timers. Next, BIOS or UEFI firmware. This is your bootloader or your pre-OS environment. So this is embedded software stored on flash memory, and it abstractly functions as a primordial interpreter that initializes your hardware, provides a bridge between bare metal and the OS, and controls security features like secure boot and TPM integration. We'll get to TPM at the end. Next, storage controllers. These are intelligent input-output interfaces. Present in SSDs, that is solid-state drives, or as part of the motherboard, such as in NVMEs or SATA. This uses firmware to translate logical file operations into physical data access and performs wear leveling, error correction, and caching. This often exposes smart features for health monitoring and performance tuning. Let me know if I read that sentence weird. Next, we have network interface controllers, or NICs. This is hardware embedded firmware and driver support, and abstractly operates as a data transceiver with protocol intelligence that handles packet queuing and offloading tasks like checksum or encryption, and also handles traffic shaping. In other words, it communicates with your Wi-Fi, but it may interact closely with like TPM to make sure that the data it's sending and receiving, well, mainly receiving, is valid data, that there are not too many errors in it, that it can still recover what it is you're supposed to be downloading. Next, sound card or audio codec. That is encoder and decoder. That's what codec means if you ever see it out in the wild. So this is your media processing unit. This is hardware plus drivers and DSP firmware. These convert digital audio into analog and vice versa, and provide software-controlled mixing, filtering, and spatial effects. Third to last, we have display output stack, which is GPU plus drivers plus compositor. This features software drivers and a compositing window manager coordinate to translate 2D or 3D output into final pixel data, handle multi-monitor layouts, refresh rates, and display protocols such as HDMI or DisplayPort, and synchronizes frames for smooth visual output, which is VSync or adaptive sync. Second to last, penultimate. We have peripheral interfaces, that is human input pipelines. So these are your devices like keyboards, mice, webcams, and game controllers. These contain embedded firmware themselves and may communicate via USB or Bluetooth, and rely on software drivers to expose functionality to the OS and applications. And finally, we have TPMs, or Trusted Platform Modules. This is a secure crypto processor with embedded software. Crypto as in cryptography, not as in crypto coin, although, funnily enough, crypto coins are based in cryptography, so in an abstract way, I suppose they are related. This abstractly acts as a root of trust for security operations like storing encryption keys, validating system integrity, and also supports features like BitLocker and secure boot chains. So this is what handles a lot of your system's encryptions and decryptions, and it's required on all PCs, on all Windows PCs starting with Windows 11, I believe. Something like that. Anyway, that will do it for today. I hope you enjoyed. I hope you learned something, and I hope to see you again tomorrow. Reminder, we're doing the Beast tomorrow, which means something theology related. But then after that, we might get back to some software, hardware, computer-ish stuff. I have like 2 or 3 more topics in that field. So, that'll do it. Take care. See you tomorrow. Take care again. Bye-bye.